A density curve is how you see that smooth curve like that. What that means is there is data that is under it. All of your data is equal to the number 1, which means it has 100% of the data. So remember, we have this curve here, and all of your data is equal to 1. We're going to be looking at this density curve in just one way. In this class, because we're regular statistics, we're only going to be focused on the normal distribution. So, once again, what's really important is that this equals to 100%. Or just 1. Sorry, that color was weird. So it's equal to 1 or 100%. Make sure you write that down. Because if you do the work and you realize that you have something that is greater than 100%, that means that you did it wrong. Okay, so jot that part down in your notes. Alrighty. Let's talk about normal distributions. Normal distributions are a special type of density curve. We have the shape is always symmetric and single peak. Okay, so that part's really important. Also, this is the most important part. The center is mu, or the mean. So your center, the thing that's right in the middle, is your mean. We also write it like mu, which is just like a U-ish looking thing. Lastly, we have our variability or our spread. So the standard deviation measures the distance. So if I was going to measure the distance here, I'm going to expand it. If I was going to measure the distance here, I would do the mean plus the standard deviation. Here would be the mean plus 2 standard deviations. So that's how we're going to be making our curves. And we have a lot of practice to do today. I'm going to do it with you. Now, if I go the other way, to the left, I'm going to do the mean, but I'm going to subtract the standard deviation. If I go farther, I'm going to do the mean minus 2 standard deviations. So the standard deviation gives me my distance. So every time I go to another standard deviation, I'm either adding if I'm going to the right, or I'm subtracting if I'm going to the left. So remember, the mu is mean. Theta is the standard deviation. What does it look like? It looks like the circle in the line. No? Oh, it's below? I'm so sorry. Better? Kind of? Here, I'll write it at the top. Thank you. So remember, if I go to the right, I'm adding theta. I'm adding the standard deviation. If I go to the left, I'm subtracting it. We will see a few examples about it, actually when we do our work. I'll give you a moment because this part was the most important part. We're just going to quickly talk about why it's important, like where do you see normal distributions, just for funsies. This is actually a very popular discussion in statistics. I just want to tell you why it's important and where you see them. Have you ever heard of something being on a curve? Like someone grading you on a curve? You ever hear about your teacher curving your grade? No? You just don't curve your grade so they don't tell you the truth? That's me. Have you ever heard someone say a bell curve? Have you ever heard someone say that someone was unusually smart? Like someone is smarter than average, above average, below average. Okay, so using normal distributions, you can actually calculate that. Okay. All right, moving on. So normal distributions, just quickly. All right, normal distributions are good descriptions of real data. So we use it when people take scores on tests. So like IQ tests, there's a normal distribution. So we know the average IQ. We know those that have an unusually high IQ and those who have an unusually low IQ. We also do it for characteristics of biological populations. So in science, you may see them use a curve like this. You may not have talked about it, but that's how they use certain things like that. So if you're into the sciences, if you're into data, so any type of data science, data analyst, business, marketing, anything where you have someone's information, you will see a normal distribution. Let's move on. Okay, this one is so important. This rule. So, they have this certain property, and I'm going to break down this property for you today in your notes. So you're going to want to write this down, and then write down the next thing that I do. Okay? So, if you look at these numbers here, these stand for standard deviations. We always have the center. Now remember, class, what's in the center? The mean or the standard deviation? The mean, okay? So I'm going to put mu right there. Write that down, okay? Mu goes right here. So the mean is always in the middle. We always have 3 standard deviations to the right, and we always have 3 standard deviations to the left. This highest part here, this is usually like the average people. So this M is like average height. Notice that there's like a lot of kids that are like my height. I'm like 5'5", right? So let's say you in between like 5'3", 5'6". You like average height with me. So about 68% falls within the first standard deviation. So most people are average. Sorry, hate to break it to you. You're still great though. Okay? Most people, 68%, are within the average, and that's okay. Now, if you're not living up to your potential, that's the issue. Okay? Now, let's talk about the next part. There's now a group of people who are slightly above average. Let's say if I have my 5-footers and I have my 5'9'ers, you know. You tall, you short, but more of you exist, you know. If someone says, oh, I'm 5'9", you're not like, damn, you know, you're just 5'9". Ooh. I'm going to still ask you to get that thing on the top shelf, though. Okay? So, about 95% of people are within 2 standard deviations. 2 standard deviations below and 2 standard deviations above, right? Now let's talk about some really short and some really tall people. Okay? This part right here. Now these are the kids. I want you to just think about the kids in your class. You got some real tall people that when I see them, I'm upset because the weather must be different up there. Or you have some other people that may not have grown. They just real short, you know. between all three of those. So I would say that's almost everyone here at signing 10 in terms of height. You have the really short people, really tall people. Notice how by the picture that there's not that much of them in the green. Okay? There's one more set of people that we don't really talk about. The people that are above 3 standard deviations and below 3 standard deviations. Actually, these are our outliers. Those are the people that you may see in the world records. People who are like, Shaquille O'Neal. You don't see a whole bunch of Shaqs walking around. Have you seen Homie in person? You don't want to. It makes me question my life. It's ridiculous. His size shoe, he cannot get it. He has to get it freshly made. I refuse. So keep that in mind. I'm going to give you one more picture that you need to copy down, okay? And I'm going to copy down the picture that I gave you in your classwork. So I'm going to move my screen. We're going to make us a normal distribution. Now this normal distribution you're about to make, you want to keep this forever. This normal distribution is going to make your life so much easier. As I'm trying to make this pretty. Come in! It's unlocked. Hey, sunshine, come on in. All right, so everyone should create their normal distribution. All right, so does everyone have this picture? Okay. Now, what's important about the 68, 95, 99.7 rule is that it only shows you what it is between the two. I'm going to split up the data for you, so that way it's going to make your life a little easier, okay? And I'm going to quickly explain the math behind it. So, first we have the middle. Class, what's in the middle? The average or the mean? Right. Okay, so no matter what, in the middle you have your mean. Okay? Do you remember how we talked about how in between the first two here? From -1 to +1 is 68%, right? What if I only wanted to know the positive standard deviation? We're going to actually split that in half. So I'm going to make some more lines. First standard deviation. Second standard deviation. I'll keep going just for the sake of your time. So I'm using different colors. Please use different colors. There's these pink boxes at your table. They have colors in them. And I'll wait for you. Is that important? I promise you're going to be like, Miss, I don't get it. I'm going to tell you. Did you draw it? No. Suck this up. you get 68%. Okay, so next we have 13.5% is here. Next, we have 2.35%. And last one. This one is one that I think a lot of my students forget about. They get mad, especially in Khan Academy, because they get it wrong. This one in the middle here is 0.15%. Once you have these written down, oh, let me make sure I give you the standard deviation. There's all the standard deviation. Negative standard deviation, negative 2 standard deviation, negative 3. So once you're done with that, we're actually going to go into your classwork, and we're going to do the first page together. Then we'll be done. So if you're done, make sure you have your worksheet out. We're all going to do the first page together.